Welcome to the hypercar speedboat build project, an ultimate sports hypercar hybrid design, starting with grinding away the foundational composite hull. The technician is dismantling the mechanical components. Disconnecting the fuel lines and removing the two-stroke engine helps redesign the center of gravity. Disconnecting the drive shaft from the pump chamber. The engine is completely removed from the engine bay. Using an angle grinder to cut away the old floor structure, combining a hammer and crowbar to break apart the foam layer. Mechanical force peels away the fiberglass floor panels. The old reinforcing structure is being cleared out. The technician smashes the tightly bonded soundproofing foam. The entire rib structure of the hull must be removed. This creates empty space to build a new flat floor. Each piece of material is meticulously pried up. Next, a high-pressure washer is used to clean the hull, thoroughly cleaning away dirt and composite residue. A clean surface determines the adhesion of the epoxy. Afterwards, the grinder is used on the jet pump mount, leveling out defects to create a micro-rough surface, removing the intake grate of the jet pump system underneath, ensuring optimal torsional rigidity for the frame, cutting away excess material with an alloy cutting disc. Placing a Formica sheet as a mold to shape the new floor. Brushing on a blue gel coat layer as the foundation. Laying down multi-directional structural fiberglass mats. Peeling off the mold to reveal a perfect composite surface. Chiseling away the red silicone sealant, sealing the drive shaft, hollowing out the technical chamber using a cutting machine. Fiberglass dust flies everywhere during the cutting process. The protective structure for the pump shaft has been detached, grinding the surface edges in preparation for joining the new module. The old glue is scraped away completely down to the base, reinforcing the water pump base and battery bracket. Rolling fiberglass to completely seal the internal equipment cluster. The hull is flipped upside down to wash the exterior. Installing a new jet pump mounting box at the stern. Applying thick epoxy resin to seal the assembly gaps. Adding fiberglass to bond the load-bearing joints. The resin pressing must be even to achieve a monolithic finish. Cleaning the metal framework bars with a bench grinder. Tightening with a wrench to prevent circulation pump pressure leaks. The 3-cylinder engine is carefully lowered onto its mounts, connecting the signal cables and CDI ignition system. Installing the water box muffler to eliminate noise, positioning the muffler onto the rubber vibration dampers. This paint layer helps minimize hydrodynamic drag. The jet pump system's bolts are firmly tightened. The battery-powered impact wrench ensures precise torque, flipping the boat back in the workshop to prepare the electrical system. Drilling and installing positioning screws for auxiliary components. Screwing down the inner jet pump assembly. Installing brass fittings for the cooling water lines. The main exhaust gas pipeline is completely connected. Test starting the powerful 2-stroke engine block. Moving on to fabricating the upper cabin frame. Using a chop saw to measure and cut galvanized steel square tubes. Setting up the central load-bearing skeleton framework. The technician tack welds the corners into shape using an arc welder, grinding welds flat to avoid stress concentration points. Bending flat steel bars to create aerodynamic lines, the mechanic proceeds to tack weld the curved steel bars. They form the arched framework of the cockpit cabin. The electric arc melts the metal to bond the structure together. The aerodynamic framework is gradually taking shape. Continuing to cut short sections of galvanized steel pipe, using a sledgehammer and a solid metal cylinder, manually bending the steel pipes. This requires an excellent feel for force to achieve precise curvature. Welding the diagonal structural bars to the main frame. Deep penetration welds ensure rigidity against wave impacts. The entire upper hull framework model has been completed. This mesh acts as a foundational bonding layer. It will hold the modeling clay that is about to be applied. The 1-to-1 scale model sculpting process officially begins. An incredibly complex 3-dimensional spatial structure, securely covering the entire framework with blue, flexible plastic mesh. using zip ties to tightly secure the mesh to the steel. Thickly applying clay to the bow and the side air intakes. Precise calculations are required to optimize aerodynamic downforce. Using bare hands to press the clay firmly to increase density. Spraying water to soften the surface for easy detailing. Using a plastic scraper to smooth out the swept-back curves. Refining every millimeter to perfect the shape. Perfect cross-sectional profile. Adding more material to the missing spots. The front hood surface is gradually becoming smooth and sharp. Complete. The sculpted model block features a hypercar-style design, a sculptural masterpiece combining both speed and aesthetics. Using a roller to apply a layer of orange release agent. It helps to easily separate the mold without damaging the model's surface, continuing to apply a blue gel coat layer over the entire model. This will be the surface layer of the negative composite mold, spreading out high-strength cross-woven fiberglass cloth. Using a brush to apply liquid polyester resin, soaking the fibers thoroughly, continuously rolling to squeeze out air bubbles to ensure there are no structural voids. The amount of resin and fiberglass is carefully calculated, so the mold won't be brittle. Mixing polyester putty with a hardener. A high-speed mixer helps make the mixture completely uniform using a plastic spatula to spread the putty onto the newly dried composite shell, filling all the pinholes and creating a mirror-like smooth finish. Applying the putty must be done quickly before the resin begins cross-ing, completely covering the air intakes and the rear wing. Waiting for the putty to dry, a disc sander is used to flatten the surface. Fine dust flies everywhere. A respirator is required during the sanding process. Sanding removes the bumps to retain the standard profile. The boat hull appears with embossed ridges, looking extremely sporty. Using an HVLP spray gun to apply a layer of 2K gray primer. Compressed air atomizes the paint particles to adhere evenly onto the gel coat. This primer reveals defects for final touch-ups. Finally, the top mold is flawless and ready for the demolding process. Flipping the entire mold block upside down. Using an angle grinder to cut the iron frame, bright sparks fly as it cuts through, cutting away the plastic mesh and the inner steel space frame. The goal is to retrieve the thin, lightweight, and sturdy composite shell. The builder climbs right into the cabin, using his hands to scrape out the clay. The sculpting clay has now fulfilled its purpose. The manual removal must be done carefully to avoid chipping the inner surface. Chunks of clay and plastic mesh fall to the floor, using a high-pressure washer to blast away the dirt stuck inside the empty cabin. It gradually appears behind the muddy water. The inner surface of the boat cover is now completely clean, drying in the sun, ready for assembly, using an alloy grinding disc to trim the excess edges. The blade glides quickly along the pre-drawn border lines, using an airblow gun to clear away the dust stuck on the work area, cutting a thin formica sheet to make a template for the windshield, marking the positions of the side air intakes, and proceeding to score and cut, using a utility knife to cut out the refined aerodynamic lines, applying the template to the side of the hull for accurate marking. Test fitting the massive rear wing in the style of a VTBA. The temporary formica structure is being test fitted in place, measuring the gaps to ensure optimal airflow exhaust, applying a layer of blue-based resin onto the aerodynamic wing parts. This helps set the profile before wrapping them in composite, coating evenly to avoid leaving ridges on the surface, and strips of woven fiberglass are spread over the side wings. The technician uses a roller to press the liquid resin firmly. The polyester resin soaks through the fiber matrix, creating structural rigidity. A knife cuts to decisively remove the excess fabric edges. Moving on to pressing the composite fibers for the central spoiler, ensuring even pressure to completely push out trapped air. The large wing surface requires a sufficiently thick layer of brushed resin. The curing process will turn them into a solid armor, using a utility knife to trim the wing edges when the resin has just set. Its current plasticity is the golden moment for trimming, applying epoxy onto a thick fiberglass strip on a piece of cardboard. This will be a special load-bearing reinforcing splint. An angle grinder cuts the composite splint in half. Once it is completely cured, a piercing screech is accompanied by a cloud of white dust, filing the profile of the splint to match the curve of the hull. The gliding grinding technique requires absolute dexterity, wiping it with solvent and washing it clean to remove adhered dust, placing the reinforcing splint onto the wing, and use a spirit level to balance it, adjusting the tilt angle of the spoiler extremely strictly. Even a minor deviation creates immense drag. Apply fiberglass putty to the structural connection points, smoothing it out with a plastic scraper to create a seamless transition. The aerodynamic fillet putty helps distribute concentrated stress. The massive boat hull is now fitted with a spoiler. Apply lubricating grease to the propeller driveshaft assembly, taking care of the mechanical system under the hyperboat. Use a drill to make ventilation holes on the Formica sheet. Using compressed air to blow away debris, the grinder continues to cut triangular air intakes on both sides. The design simulates shark gills to draw in cooling air. A large composite block is peeled off the boat's hull. The windshield frame begins to take shape with sharp cuts. Sand the windshield edges to create an aerodynamic curve. Dust flies continuously under the friction of the high-speed grinding disc. Test fit the cabin module to check the edge clearance. Any discrepancies must be compensated for with reinforced putty. Cut and assemble longitudinal foam partitions on the rear canopy. They create a base for the Formula 1 style roof scoop. Wrap this structure completely in a loosely woven checkered fiberglass mesh. A roller works the liquid polyester resin deep into the core. Use sandpaper to smooth the edges, removing excess fiberglass. Moving on to apply fiberglass mesh to the front bumper of the bow. Press the composite fabric firmly along the downward curve of the bow. This increases the hyperboat's wave-piercing capability. The sander levels the uneven surface on the front hood edge. The builder completely lifts the open cabin cover off the main body. Machine and cut U-shaped directional aluminum tracks. These are components for the sliding system to automatically open the cabin cover. Drill and apply glue to secure the aluminum rails to the edge of the cockpit. Install the Formica partition panel to cover the front luggage compartment. Apply reinforced fiberglass mesh to make the partition waterproof. An orbital sander smooths the entire sliding roof surface. Place the dual aluminum sliding rails and screw them in place. Install the canopy to test the manual sliding mechanism. The builder sits in the cockpit and tries pulling the canopy. The sliding rails operate smoothly, matching the design perfectly. Moving on to fabricating the electrical opening and closing system. Use a lead screw and a brass nut, assembling them with a support bearing and a retaining clamp. This system converts rotational motion into linear motion. Install the lead screw parallel to the guide rails. This mechanism ensures a stable pulling force on the boat's roof. The control circuit uses a 12 volts relay module. The technician draws a motor reversing circuit diagram. The diagram includes a DC motor and 2 limit switches. Solder the rectifier diodes to the switch pins. The limit switch will cut power when the sliding roof reaches the end of its travel, preventing mechanical jamming and motor burnout. Fully assemble the safety contact assemblies. Connect the circuit to a 12 volts battery for testing. Use an RF remote control to activate and wait. The motor spins, triggers the limit switch, and shuts off automatically. Press the reverse button. The motor spins in reverse perfectly. Screw the limit switches securely onto the sliding rails. Integrate the entire lead screw motor assembly into the roof. Press the remote, and the canopy automatically slides open, looking incredibly cool. The linear motion operates smoothly with absolute precision. A close-up shot shows the lead screw in operation. The transmission mechanism works flawlessly under load. The technician is dismantling an old jet ski shell. Use a grinder to cut out the water exhaust mounting bracket. Measure and install a composite panel to seal the engine compartment. Spray 2K gray primer over the entire hyperboat. The primer fills in the tiny pinholes on the surface. Spray with water to completely remove any excess paint dust. Applying yellow putty is done in the tight corners. Smooth the putty over the joints and contour lines. The orbital sander quickly buffs away the excess putty. A soft sanding pad helps conform to complex curved profiles. Use a sanding sponge by hand to smooth out the aerodynamic edges. Wet sand the entire hull using a pneumatic sander. The water washes away paint residue, resulting in an ultra-smooth surface. The hull is now ready for the main color coding process. Use yellow masking tape and plastic to cover the unpainted areas. The masking technique requires meticulousness, masking the edges with tape to protect the cockpit and side steps from paint overspray. The HVLP spray gun begins applying a brilliant red layer, polyurethane-based paint, glossy and resistant to UV rays and sea salt. The red panels hug the sides and air intakes. The rear wing is also coated in a sporty red, spraying evenly with steady pressure to ensure a glossy finish. Peeling off the masking plastic film to reveal the top-tier color scheme. The contrast between white and red creates a striking visual. Highlight. Proceeding to apply faux carbon fiber decal on the hood, using a plastic squeegee to push out air bubbles. Trimming the edges with a knife. Getting to work on. Fabricating the cockpit's center control panel, assembling it with the carbon-wrapped engine start switch. Wiring the red emergency safety kill switch. The wiring is neatly routed behind the dashboard panel, preparing the engine cover to protect against splashing water. Grinding and shaping the aluminum core for the Formula 1 style steering wheel. Shaping the steering wheel grips with specialized putty. Polishing the aluminum frame and applying carbon decal to the crossbar. Wrapping the grip area in orange Alcantara. The finished steering wheel carries a strong modern hypercar vibe, cutting Formica and assembling it into the shape of a sports seat. Wrapping it in fiberglass to reinforce the bucket racing seat structure. Finishing the seat with striking orange Alcantara. Assembling the steering wheel and steering column. Checking for mechanical play. The cockpit is complete with a carbon and orange-red color scheme. Drilling holes and fastening screws to secure the acrylic sheet. Acting as the windshield. Adding a waterproof rubber gasket to the glass trim. Applying black silicone sealant around the edges of the windshield to ensure absolute water tightness when operating at high speeds. Fully assembling the hull's side panels. The hypercar speedboat masterpiece now has its complete look. The boat is hoisted onto a specialized trailer using a winch. The wheels roll, moving the masterpiece toward the riverbank. The trailer slowly backs down into the calm water. The speedboat floats perfectly balanced. The technician presses the remote and the canopy slowly slides open. The electromechanical mechanism operates smoothly on the water. The driver confidently steps into the sporty cockpit, sits in the bucket seat, and tightly grips the Alcantara steering wheel, turns on the power switch, presses the engine start button, and the powerful engine block roars to life. The jet pump sucks in water, creating immense rearward thrust. The hypercar surges forward, tearing across the water's surface. The drone camera closely follows every spectacular sharp turn. The V-hull cuts through the waves smoothly and corners with incredible grip. The rear wing system applies aerodynamic downforce. The stern doesn't fishtail at all, even when cornering at high speeds. Opening the throttle wide, the engine reaches maximum RPM. A long trail of white water stretches out behind the rear jet system. The aerodynamic design of the bow cuts through the wind extremely efficiently. The wind-tearing speed delivers an incredibly thrilling experience. The drone captures a close-up of the side air intakes at work, supplying a massive amount of air to cool the engine compartment. The hull tilts at a beautiful angle, gliding like a red arrow. The screaming two-stroke engine sound echoes across the river. Throttling down, the speedboat decelerates and glides smoothly toward the dock. Incredible maneuverability in tight spaces. The canopy roof slowly slides shut via the electrical system,
sealing the cockpit to protect the interior from moisture. The static shot shows off all the beautiful muscular lines. A perfect combination of marine and racing technology. The brilliant red paint stands out under the radiant sunset. The faux carbon fiber details enhance its sporty elegance. A project handcrafted with passion and high technical skills, proving the builder's limitless creativity. The hypercar speedboat has far exceeded all initial expectations, ready to conquer any body of water with a dominant presence. The test drive concludes perfectly without a single flaw. This mechanical masterpiece is officially and excellently completed. Thank you for following the entire speedboat project. Stay tuned for the next mechanical masterpieces from us.